Good evening, everyone, and welcome to the first meeting of the Royal Astronomical Society of Canada Ottawa Centre for 2022. My name is Mick Wilson. I'm your new meeting chair for this year. Dave Chisholm, having served his penance, has passed the baton on to me, and this is my first go at the helm, so be gentle with me. Chris, next slide, please. So the usual warnings, yes, we are on Zoom. This is being recorded to our splendidly resourced website for posterity. I remind you that use the Q&A, not the chat box. If you need to ask questions of any of the panel members or presenters, the chat box comments will and can be seen by all, so be careful what you say there. And of course, not to go clicking on unsolicited links that might appear there. Finally, the raise your hand function is disabled, so no point going there. Next, Chris. So, overview of tonight's program. I'll be introducing myself. Dave Chisholm I'll be introducing myself and reviewing a few things like members in the news. Dave Chisholm will do his monthly review of Ottawa Skies. Then we get to Jim Thompson doing a double header. I don't know how Jim bribed Dave to get this, but we've got two presentations by Jim Thompson tonight. The first before the break on mini refractors. Following the break, a series of recommendations about measuring backyard light pollution. Our third presentation will be Rick giving us an overview of Skylights for 2022. Then we'll have the usual round of observations, the monthly challenges, and any other subsequent announcements. So, Chris, can you now highlight me, please? And then I'm doing the sharing thing because sharing is caring. And there we go. Okay, so this is my background, or an introduction to my background, and where I think we can sort of see these RASC meetings perhaps going over the next couple of years, because I do have a couple of minor modifications that I would like to introduce. First of all, as you may have guessed, I'm neither royal nor Canadian, and in fact hail from the deep south, aka Australia, and more specifically the Centre of Scientific and Intellectual Learning in the Southern Hemisphere, a charming place called Warragul. You need to memorise that name because there will be a short test at the end. Where I come from, this is what the sky looks like. That shot could have been taken on the beach where I grew up as a kid. We have splendid views of the Milky Way and all that goes along with that. More to the point, in Australia, we have at least 20,000 and maybe 60,000 years of astronomical heritage. The Australian Aboriginals have, at least for 20,000 years, noted a dark constellation made up of the gas clouds stretching from sort of the Southern Cross through the galactic centre and out to the west, and they recognise that as an emu. That's amongst other constellations that are known all over the continent and obviously date from very early times simply to have been able to spread across the width of Australia. So a night sky like this, out camping, is common territory for us. And knowing about this type of legacy and highlight gives us, I think, a special feel for the sky. In that spirit, I would like to introduce a couple of the first minor modifications that I think I could helpfully bring to the Ottawa Centre. A few minor adjustments. The first is a minor spelling change. Ottawa is, it's a nice word, it's a good word, it's a very Canadian word, but it doesn't travel well internationally. And so I think a slight rebranding, nothing major, introducing the concept of the Ottawa Centre rather than Ottawa could be in order. And I would propose that we move forward with that, along with the fact that astronomical, that it's maybe time for a bit of a new flavour there as well. Thirdly, the old Ursa Major that was up there in the seal, I think it's time for a bit of a remake there. And my proposition is, as you will see, the Southern Cross. Why the Southern Cross, I hear you ask? It's not even visible from Canada, simply because from a Southern perspective, it is and has been voted internationally repeatedly to be the best constellation of all. And therefore, if the RASC is going to live up to international standards, why second for a second-rate constellation on the seal? So the Southern Cross it is. I worked for the UN for 25 years, so I know all about international diplomacy, voting, how the lobbying works. In that international sense, here is the voting register. Australia, in 1901, when federated, placed the Southern Cross on its national flag, and it remains there to this day. Brazil has voted for the Southern Cross on their flag no less than 4 times. And there are a lot more Brazilians than Australians, so I think that's very important. New Zealand introduced their version of the flag in 1902. They decided to simplify the Southern Cross. 5 stars was a bit tricky for most New Zealanders, apparently. So we let them get away with 4, but it is still recognisably the Southern Cross. Papua New Guinea, when it established itself as an independent territory in the 1970s, again, opted for the Southern Cross with all 5 stars. Samoa, 1962, not to be confused with American Samoa. This is the real proper Samoa. Again, the Southern Cross, slightly distorted, perhaps because of their perspective at that particular latitude. Finally, Tokelau, again, put the Southern Cross on their flag in 1982. So we've got a total of 6 international entities that have all voted for the Southern Cross, and therefore, by definition, I believe it is the best constellation in the sky and ought to be adapted to the RASC seal, at least for the duration of my chairmanship of these meetings. So with those few minor changes, I think we can switch back to the usual schedule here, Chris, and I will stop sharing at this point. So, the question. I presume I'm still on mic, am I, Chris?
You are.
Okay. So, whoops, back us up, back us up. Okay, so then for those of you who are joining the meeting, perhaps for the first time or the first time in a while, there's always the question of why you would want to join the RASC in general, the Ottawa Centre in particular, particularly when it costs. You can see there regular membership, family membership, youth and student memberships are all available. They're all significant, but I will argue that they are worth the money. Next slide, Chris. So in terms of material assets, what you gain, at least in normal circumstances, are access to our telescope and book libraries. They're both at the Aerospace Museum and not available, but they will be sometime soon. You can have access to the Fred Lossing Observatory, members only facility out near Almont. pretty good skies and some superb equipment there. You can also participate in the various RASC observer programs and gain your certification. Next slide. In terms of information assets, you've got bi-monthly Sky News, the RASC's Journal, a more scholarly publication, very good stuff. Of course, the internationally famous and well-recognised Observer's Handbook, and you get the monthly Astronauts, the local newsletter for RASC Ottawa, online, through email, and of course on our beautifully provisioned website at ottawa.rasc.ca. I would like to put in a personal note at this point. I believe there's a more important set of assets and benefits that derive from your membership with the RASC Ottawa Centre, and that's the people. Anything that I've described so far in terms of information assets, you know and I know we can all get it online these days. You don't need to join RASC to garner that sort of information. What you can't gain access to online are the skills, the experience, and the expertise of both the members of the society and the invited guests that we bring in each month to give their important contributions on the developments in astronomy, the history of astronomy, technologies underpinning astronomy. Those, in my experience, in the 4 years I've been a member, are invaluable. And so I encourage you to join, get the books, get access to the library, but also meet and interact with the people that make the club what it is. Next slide, Chris. So our total membership count of recruitment during 2021 was 70 new members, which, Chris, you will back me up, I believe, is a pretty good harvest for difficult times such as we're having with COVID. So far in 2022, we've got a dozen new members, and I extend a warm welcome to all of you, and again, hope that you will participate, ask your questions, and make yourself known to the other members of the centre. Next slide. Members in the news, roll it forward. So Jim Thompson, our speaker tonight, runner-up in the Sky News solar and planetary, or sorry, lunar, solar and planetary category for best photo of the year. So his fabulous moon mosaic that was presented at the meeting here a month or two back has been recognised as being amongst the best that Canada can produce. So well done, Jim. Next. Andrea Giron has also done pretty well for herself in terms of the astro editing portion of Sky News, with her beautifully rendered deep portrayal of NGC 7331 and all the neighbouring galactic objects, deep sky objects in that part of the sky. You'll see that she acquired that using the RASC robotic telescope, which is another one of those assets to which you can gain access through your RASC membership, and perhaps we need another presentation on that sometime. Next, please. Curtis Breslin, one of the observer certificates, as I mentioned in the previous section, acquired his certificate for exploring the universe, observing stars, recording program targets, and so on, maintaining his log. So well done, Curtis. Next one is Gary Boyle and his presentation on CTV, I think it was, on the occasion of the launch of the James Webb Telescope and its subsequent deployment efforts. So well done, Gary, and congratulations and best wishes for the upcoming retirement. Next one. Finally, the Backyard Astronomer's Guide, a 30-year classic now in its 4th edition, has paid minor homage to RASC Ottawa and to astronauts with a small quote from, I believe it was Rolf Meyer in about 1978, where he was paraphrasing Star Trek and the idea that our purpose is to boldly look where no human has looked before, and mainly to have fun. And I think that's a sentiment that we'd all like to cleave to. With that, I believe I can now hand over to Dave for Ottawa Skies for January 2022.
There we go. It works better if I mute myself. There we go. Okay, folks. So here's what's happening in the Ottawa skies for January 2022. So if we go to the next slide. It's just a quick summary of the planet visibility for 2022. As you can see, there's a bit of dearth of planets in the evening skies until sort of August time frame. A lot of them are in the morning. Some of them are not visible at all. And if we want to see all sort of the major planets, we're looking in sort of the October timeframe. In any case, this is just a quick view, particularly if we're playing star parties and so on, as to what's visible up in the skies.
And
Next
Dave,
slide.
it's Chris. If I can just interrupt and comment on this slide. This kind of slide people can't absorb in 2 seconds here on a screen, but Dave's slides like this will show up in Astronotes, where you'll be able to see a copy of this and study it and save it.
Yeah, pin it up on your refrigerator or something. Yeah. Okay, so here are the moon phases I've highlighted tonight. The full moon is on the 17th, 17th of January, and it's known by early indigenous peoples as the wolf moon. And it's the time of the year when the hungry wolf packs howl outside their camps. It's also been known as the old moon and the moon after Yule. Haha, you missed it. But I did put this slide up last month. The Quantrids meteor shower was January 3rd and 4th. I just had to put it in here for completeness. It's a fairly narrow band in terms of its visibility. You may see some now, but they're pretty well all gone by the time of this meeting. Sun, as you can see, the days are getting longer as we move through the month. Mercury, greatest eastern elongation, so that's where it's furthest apart from the sun. So you'll be able to see it low in the western sky just after sunset on January the 7th, which is today. So, okay. Venus is not visible. It's rising and setting with the sun, as is Mars. Jupiter is visible in the early evening, so it's starting to set earlier and earlier as we move through the month. Saturn's visible in the early evening, first half of the month. By the end of the month, it's rising and setting with the sun. Uranus is visible in the evening, and Neptune is also visible in the evening. And here is my comic for the month. I just want to thank Mick for his wonderful introduction there. I always have to explain when I'm doing my astronomy presentations that Australia has a Southern Cross. They don't have a Southern Star. So I have to explain to them how the Australians have to know their math. So they draw a line through the Southern Cross and through Alpha and Beta Centauri, where those two lines meet at the horizon is the South Pole. We got it much easier up in Canada. So the Australians have to be smarter when it comes to math and astronomy to find their way around. So thanks again, Mick, and I'll turn it back to you.
Righty. And so with that, Jim, are you ready to take over and introduce us to the world of mini refractors?
Yes, I am. I'll just share my screen here. So hopefully everybody can see that all right.
That's good.
So good evening, everyone, and Happy New Year. This is the first of 2 talks I'm giving tonight. This one entitled Mini Refractors, or It's Not How Big It Is, It's How You Use It. In this talk, I will introduce you to the idea of the mini refractor and discuss some of their benefits. First, let's clarify what exactly I mean by a mini refractor. Generally, I'm talking about a telescope with an aperture or a diameter of 30 to 50 millimeters, a focal length in the 135 to 250 millimeter range, and a mass in the 300 to 1500 gram range. So we're talking about something that will fit comfortably into your hand. Whoa, geez, how'd that picture get there? Sorry, that's better. Yeah, something that fits comfortably into your hand, like a guide scope or a finder scope, but not just any finder scope. We're talking about something with very high quality optics, like an ED doublet or an APO triplet. Most of the available offerings even come with a field flattener to help provide nice pinpoint stars right out to the edge of the scope's field of view. At the moment, there are 6 models of mini refractor available on the market. The first on the market was the William Optics Red Cat 51. This high-quality Petzval design has set the standard by which all the other mini refractors are compared. Next on the market was the Evo Guide 50 millimeter from Skywatcher, followed about a year and a half ago by the TPO Ultra Wide 40. I have both the Evo Guide and the Ultra Wide, and I like both of them very much. With the recent growth in popularity of mini refractors, a new brand has come on the market, Ascar, who has offerings in 3 sizes, 30, 40, and 50 millimeter apertures. I anticipate we will see more brands come on the market as the popularity of these scopes continues to increase. Now, with all this talk of mini telescopes, some of you might be saying, I thought bigger was better. Well, that sort of depends on what it is you're trying to achieve. There are a number of reasons why a bigger telescope may not be better for your application. First off, let's talk about convenience. Remember that the best telescope tends to be the one that you will actually use. Mini refractors have a number of things going for them in that department. For one, their small size makes them extremely portable. They can easily be packed into your camping or hiking gear, or in your carry-on luggage if you're traveling abroad. Mini refractors are very versatile. You can use them as a finder scope, a guide scope, or a wide field telescope. Finally, they are easy to use. They all come with a built-in helical focuser. Their low mass means they are easy to drive using the most basic of mounts. And their large fields of view means the need for accurate tracking is reduced. So indeed, these small scopes are convenient. But isn't it at the cost of light gathering ability? Well, I will begin to answer that question by first asking another question. Which of the following 2 telescopes produces the brightest image? By brightest, I mean if you put the same eyepiece in each scope or the same camera, which one produces a brighter image? The first is the Canada-France-Hawaii telescope. It has a 3.6 meter aperture primary mirror and a focal length of 13.5 meters. Or the second scope is a Takahashi Epsilon Newtonian reflector with 130 millimeter aperture and 430 millimeter focal length. Now, if you care to make a guess, go ahead and put it into the chat box. I'll give you a couple of minutes to put in your guess. Okay, we've got a guess from Calvin. Anybody else want to take a guess? Okay, we have a vote for the Canada, France, Hawaii. Any other guesses? All right. A couple more for the TAC and another for both the same. Okay, so if you voted for the Takahashi, you are correct. To understand why this is so, consider, if you will, the light bucket analogy. In this analogy, the size of your telescope primary is represented by the diameter of the bucket, and photons as drops of rain. Conventional wisdom tells us that if you have a larger bucket, you can collect more raindrops in the same amount of time. But what this analogy ignores is the fact that telescopes only gather light that is visible within their field of view. And field of view is defined by the scope's focal length, not its aperture. The measure of how efficiently a scope gathers light is called its focal ratio, and is equal to the scope's focal length divided by its aperture. The smaller the focal ratio value, the quicker the scope gathers photons. Now let's return to my earlier question about which scope produces a brighter image. The Canada-France-Hawaii telescope has a focal ratio of 3.75, and the Takahashi has a focal ratio of 3.31. Although these are both fast telescopes, the Takahashi is slightly faster and is thus able to produce a brighter image, all other things being equal. This is why mini refractors work so well. They all have relatively fast focal ratios and so are able to collect light efficiently. If this concept still seems hard to grasp, keep in mind that the Takahashi here has a much shorter focal length than the Canada-France-Hawaii telescope, and is therefore gathering light from a field of view that is 31 times the size of the CFHT's field of view. That leads us to the next discussion point, field of view. Recall that a shorter focal length translates to a larger field of view. This graph illustrates the relationship as plotted for a variety of different camera sensor sizes. The relationship is linear. So if you have the telescope's focal length, you double the field of view. SCTs and other large reflecting telescopes tend to have focal lengths in the 1500 millimeters and up range. Refractors tend to sit more in the 500 to 1500 millimeter range. Mini refractors, as I mentioned earlier, are in the 135 to 250 millimeter range. Thus, you can expect mini refractors to give you a field of view on the order of 10 times larger than what an SCT or large reflector would give. With such a large field of view, the mount tracking accuracy needed to use these scopes is low, saving you time and/or money with your mount setup. The wide field of view can also provide a completely different perspective on the night sky, putting what you're looking at into a different context. This is the part that I really enjoy. To show you what I mean, I've brought along 3 examples. The first is an object that you can observe right now. NGC 7635, the Bubble Nebula, located near the border between Cassiopeia and Cepheus. This view of the Bubble Nebula was captured on my 10-inch Ritchie-Chrétien telescope with a focal reducer added to give a focal length of 1625 millimeters. At this focal length, the details of the bubble are clearly visible. However, the context is missing. Switch now to the view through my TPO ultra-wide 40 millimeter. Now we can see that the Bubble Nebula is not an isolated object. You might not even be able to see it, so I'll put a little circle around it here. It's right here. The nebula is, in fact, part of a much larger neighborhood of emission nebulae, interconnected by streamers of cold gas and dust. We can also observe the passage of time in this wider view, as it contains open clusters like M52 down here, the Dormouse cluster right here. We can see mature star-forming regions like the Bubble Nebula itself, as well as the Northern Lagoon right here. Young star-forming regions just getting going, like the Cave Nebula up here. And finally, particularly dense dark nebulae like LDN 1216 up here and 1230 down here, that someday might also become star-forming regions. My next example is of the Crescent Nebula, catalog designation NGC 6888, which can be found in the middle of Cygnus the Swan. This image was captured using the same 10-inch Ritchie-Chrétien as before, except this time with a monochrome camera, my Malincam DS432M. Intricate details are visible in the nebula at this focal length. However, the non-uniform background surrounding the object is curious. Is it just a weird gradient in my image or something real? Let's zoom out and take a look. At a focal length of 180 millimeters, we can see that in fact, the Crescent Nebula sits in the midst of a vast area of nebulosity. The brightest portion surrounds the central star in Cygnus, Saturn, and is designated IC 1318. This is an older image, actually, that I captured using an old 180 millimeter camera lens. Playing with this lens is what got me interested in mini refractors in the first place. My final example is another summertime treat, M8, the Lagoon Nebula. I very much enjoy observing this object as it is ripe with layers and layers of detail. Star formation at many different stages can be found when observing the object at a long focal length. Even more fascinating, though, is the view at a wider field of view. As with the Bubble Nebula, here too with the lagoon, we can see that the nebula is part of a much larger structure. That structure includes the neighboring Trifid Nebula, which is in the upper right, and NGC 6559, which is to the left of M8. With a little imagination, one can visualize the 3D nature of this scene. The dark tendrils of gas and dust sitting between us and the billions of stars lying beyond in our galaxy's central bulge. The nebulae appear to me like dewdrops, snared in a shadowy spider's web. Many refractors make this new perspective possible, which brings us to the last discussion point: cost. Because of the small size of these scopes, material costs are much lower than for other scopes. Also, there is less technical risk associated with making small-sized, high-quality optics. With these two things in mind, one would expect many refractors to be low cost. For the most part, this is true, with 4 of the available models coming in under $500 Canadian. The RedCat 51 is priced significantly higher, but it is also more complicated optically, having 4 lens elements. It also has a number of other features that push its price up into the $1,000 range. The 50mm ASCAR scope would seem to be priced to compete directly with the RedCat, but I don't know how it compares image quality-wise. Compared to some other fast F-ratio scopes used for astrophotography, mini refractors are roughly a fifth of the price. So in conclusion, mini refractors are available at an affordable price. They are made using quality optics, and they are very easy to use. I have greatly enjoyed exploring the night sky with a mini refractor. I'm sure you will have fun with them as well. Thank you. If there are any questions, I would be happy to answer them.
Jim, excuse me, it's Mick here. I have a question for you.
Sure.
You mentioned in passing the quality of the optics and referred to ED doublets and APO triplets. Can you just clarify that for those of us who are not up with the parlance?
Sure. So one of the main aspects of the design of a refractor is the ability of the lens to focus all the different colors of light to the same focal plane. This is something called chromatic aberration. Cheaper telescopes aren't able to focus all the light to the same plane, and you can get a blue or a purple fringing around the image. Now, if you have a much more complicated lens design, you can eliminate this issue. But typically it results in using specialized glass or more than a single lens element. So an ED doublet is sort of one step towards a better quality of optic, and it uses, the ED stands for extra low dispersion glass. So it's a special kind of glass, and the doublet means that there's 2 glass components that make up the lens, one stacked on top of the other. A triplet is like it sounds, it's 3 lens elements, and apo is just short for apochromatic, which is the generalized term used to refer to scopes that have been designed to focus all of the wavelengths of light to the same focal plane. Any other questions?
There's a couple of other questions in the Q&A.
All right, I can pop that up here. Okay, the first one is from Simon. Yes, it is worth pointing out that all of the images shown in my examples were taken from my backyard in Ottawa, where the Bortle is about 9+, and you'll learn more about that in my second talk. So very heavily light polluted. Another question comes from Jeff Amy. Would you recommend a stand with a mini refractor? Yeah, yes, you still need to have some sort of a mount. Holding it by hand would still be too shaky. Like, imagine using your point and shoot camera with a 200mm lens on it. It's just too much weight to hold by hand. And as well, you still need to track to some extent, not as much as if you were at a long focal length, but you do still need to track, or else you're going to get star trails. So yeah, you still need a mount. Question from Rick Aubrey. What type of mounts do you use? What about eyepieces tracking? Those are all questions that could lead into a half-hour discussion. I have different mounts depending on what I'm doing. I have simple portable alt as battery powered mounts when I go camping, but I have a big equatorial mount that stays set up in my backyard when I'm at home. So it kind of depends on what you want to do. Maybe we should have a talk on mounts in the future, Mick. It's an idea for you.
Okay, noted. And there's a couple more, and then I think we need to close off
Move
for the
along.
break.
Okay, Dave Ham, are the mini refractors good for observing the moon and planets as well? I would say no to planets. The size of those objects in your eyepiece would be very, very small. The moon, however, I'd say that yes, with a short focal length eyepiece, you could probably do some pretty good observing of the moon with one of these little guys. Mark Kramer, final question. Would these be okay with a star tracker mount, or does it need an EQ mount for astrophotography? Yeah, you can use them on a star tracker, and people do use them on a star tracker mount, yes. I guess one final question just got in under the wire from Ken Young. How do they compare to fixed focal length photographic lenses? In terms of optical quality, they are much better. Typically, photographic lenses are designed for daytime use. And even the fast lenses, the optical quality isn't as good as what you'll get in one of these scopes. You'll get much better star quality, colors will be better. And in fact, you can use these mini refractors as a lens on your camera during the day if you want, for bird watching or whatever. All right, that's it.
Beauty.
Thank you very much.
All right, Jim, thank you very, very much. I'm sure you're going to get follow-up on questions about mounts and tracking and so on. Chris, if we can go back to the normal deck, please. Okay, so one of my minor changes is to introduce a trivia challenge over the bio break. We used to have the Messier and Moon challenges. I'm going for a broader scope here. And so we all know of Johannes Kepler, who developed the laws of planetary motion. My question for you over the break is, what was his day job? Bonus points if you can answer, who did he work for? And with that, 5-minute bio break.
We're in business. You've got some proposed answers in the chat and the Q&A.
Oh, I wasn't. Okay, mathematician, astronomer who worked for Tycho Brahe. Almost semi-right, partially correct. No bonus points. And you say there's more?
You can look in the chat box. You'll see several proposed answers.
Astrologer advisor, that's pretty good. To whom? One of the kings, don't remember the king's name. Also almost right. Galileo, no, he did not work for Galileo. Okay, can you go to the next slide? So he was the imperial astrologer and mathematician to the Holy Roman Emperor Rudolph II, King of Hungary and Croatia, King of Bohemia and Archduke of Russia, a member of the House of Habsburg that was sort of running all of Europe at the time anyway. So kings, yeah, no one mentioned specifically the Holy Roman Emperor, so I will keep my bonus prize. Okay, back to Jim. Hopefully he's had a beer and his voice is in good condition, and he will now address the issue of measuring urban light pollution. Take it away, Jim.
All right, thank you, Mick. Share my screen again. And off we go. So welcome back. And welcome to the second of my two presentations for this evening. This one being on the topic of measuring backyard light pollution. Let's begin by having a look at the view from my backyard. I live in the middle of the city, so even on a good night, I can only see a few dozen stars. On a bad night, I can't see any stars, just the moon and the planets. But that is just my own personal perception of the night sky. I wonder how bad my skies are compared to other locations. We'll find that out by the end of the presentation. But first, to be able to compare my sky's brightness to others, I need some sort of measurement scale. Enter the Bortle Scale. The 9-step scale was first proposed by John Bortle in February 2001 in Sky and Telescope magazine. He proposed it as a way of comparing the darkness of different observing sites. Each of the 9 steps in the scale are defined by the extent to which stars and deep sky objects are visible to the naked eye. Use of the scale has become quite common, with many astronomers using it as a way of evaluating the darkness of their sky and comparing it to different locations. Because the scale is based on the perception of the individual observer, it is a rather subjective way of evaluating sky darkness. Nonetheless, it is a very popular scale. Numerous sky darkness maps can be found online that use the scale. These maps are based on satellite measurements like this one is, or on ground measurements. Based on this particular map that is from 8 or 9 years ago, most of Ottawa has Bortle 8 to 9 skies. The Fred Lossing Observatory, which is sort of in this area right here, it has Bortle 5 skies. If you want to get to Bortle 2 skies, which is where the dark gray area is on this map, you're going to need to drive about 90 minutes out of the city. As I mentioned, the Bortle scale is subjective. A less subjective, but still human observation-based method of evaluating sky darkness is something called the naked eye limiting magnitude. Ooh, I just forgot to do some clicking here. The method is very easy to do. You start by going outside and letting your eyes adjust to the darkness, and then you look up. Find the faintest star that you can just barely see with direct vision. Then locate that star in a star chart or planetarium software on your mobile device and determine its magnitude. This is very quick to do, and you can in fact do this periodically through your night to keep track of how sky conditions are changing. The method does not rely on electronics, although finding a star's magnitude using a planetarium app is more precise than using a printed chart. Normally, this method assumes that the star you use is from directly overhead. With practice, you will get to know the magnitude of a handful of reference stars and will be able to quickly evaluate the sky darkness without the use of a chart. Although this method is less subjective than the Bortle scale, it is still dependent on the visual acuity of the observer. If you instead want a completely objective evaluation of your sky darkness, you will need a sky quality meter. A sky quality meter, or SQM for short, is essentially a calibrated brightness meter similar to the exposure meters that photographers used to use in the olden days. The image here is of the most common brand of SQM. It is roughly the size of a deck of cards. The device measures the brightness of the sky in units of magnitudes, or mags, per square arc second. The use of the term magnitudes here is the same as the magnitude scale used to quantify the brightness of objects in the sky, like the stars and planets. A larger value of mags per square arc second means a darker sky. SQMs are relatively inexpensive, being in the $150 range. As the sticker in this image implies, the most popular SQM on the market is made by a Canadian company called Unihedron. I have used my SQM to measure the darkness of my backyard on numerous occasions. This plot is a summary of the range of readings that I have recorded over the last few years. I have found that the readings vary significantly with the direction in which I am looking, being lower, that is brighter, when I look towards downtown or in the direction of nearby shopping or sporting facilities such as Lansdowne Park. The reading also changes significantly with the condition of the sky on the particular evening. The presence of fog, haze, smoke, or high altitude ice crystals can all impact how much of the city's light pollution is scattered back towards the ground. There is always a variation with elevation angle, which is related directly to how much atmosphere I am looking through. More atmosphere means more scattering of light. The variation in SQM reading with elevation is higher on nights with bad observing conditions, as illustrated in my plot. From my various SQM readings, my typical backyard sky brightness seems to be in the 16.8 to 17.7 mags per square arc second range. I wonder what that means in terms of Bortle scale. Well, luckily, somebody has already worked that out for us. The table shown here compares the three sky darkness methods that I have described tonight. The table can be used to convert between the different scales. Not obvious from the values in this table is the fact that all three scales are logarithmic. A Bortle 4 sky is not half as bright as a Bortle 8 sky. A Nelm 6 sky is not 50% darker than a Nelm 4 sky. To put things into perspective, let's add another column to this table. This one in engineering units of microcandela per square meter. Now we can see the very large range of brightness we are dealing with, and why using a logarithmic scale is so convenient. The last thing to note before leaving this table is where my backyard sky brightness sits on these scales. Well, not too good, to be honest. My backyard is a solid Bortle 9+, about 20 times brighter than the skies at FLO. With such terrible skies, it is not hard to understand why I have such an interest in light pollution filters. Key to understanding how these filters work is knowledge of what the light pollution's spectrum looks like. The plot shown here is my best guess at what the light pollution spectrum in my backyard looks like. I have constructed it from the information I have been able to find online in various research papers and textbooks. The spectrum is made up of different light pollution sources, The first being classic outdoor mercury or sodium vapor lighting. Next is the newer LED-based street lighting, which most of the city of Ottawa now has. The third main component is naturally occurring sky glow that is emitted from molecules in our upper atmosphere at night. There is another important natural light pollution source, the moon, but I have not included it in my spectrum construct. Based on the information I could find, I made an educated guess at how to mix these light sources together. I have not had an opportunity to confirm by measurement that my spectrum is correct, at least not until a couple of months ago. I have worked at the problem of measuring the night sky's spectrum for quite a while. I made many attempts using my benchtop spectrometer, combining it with different telescopes or camera lenses, but this effort was to no avail, as the signal I was trying to measure was simply too low. The prospect of using a spectrometer suited for measuring astronomical targets was simply out of the question, due to them being way too expensive. Fortunately, I came across a technical paper where the researcher used a telescope combined with a camera and a series of filters to measure a spectrum. Well, I have all of those things. This was an idea just crazy enough to work. The first thing I did was comb through my library of astronomical filters to come up with 11 different passbands, covering the spectrum from near ultraviolet to near infrared. The measured spectra of the 11 filter combinations are shown in the plot on the right. I then set up my 4-inch refractor and aimed it south at 45 degrees up, with the scope well out of focus in order to give a nice uniform image of the sky. Using my monochrome ASI 290 camera, I captured a reference image using no filters, being sure to set the camera exposure time so that the image was brightly exposed but not overexposed. I then captured an image with each of the 11 filter combinations using identical camera settings. Finally, I confirmed the spectrum of each filter using my benchtop spectrometer, which is the source of the data shown in the plot on the right. With my images collected, the data reduction was straightforward. I knew the percentage of light getting through each filter combo from my spectrum measurements, and the percentage of light relative to the reference frame being picked up by the camera with each filter using my images. From this, I was able to find the relative contribution to the total image brightness from each filter's passband. I scaled the resulting spectrum points uniformly to achieve the best fit with my constructed spectrum that we saw earlier. The plot on the right is the result, the blue dots being my measured values. To say I was pleased with the result is an understatement. My measured sky spectrum matches my assumed spectrum very well, with only a slight overprediction in the near UV part of the spectrum and a slight underprediction in the near infrared. So in conclusion, tonight I've shown you 3 different methods of evaluating the darkness of your night sky. Using a camera and a filter-based method, I have confirmed that the spectrum of Ottawa's light pollution is consistent with my expectations. If anyone has any questions, I would be happy to answer them. Thank you.
Thank you, Jim. I'm going to ask Chris if he can highlight me for a moment, just for a bit of a news update before getting to your questions. Let me do that. And oops, where am I looking for? Where is, okay. Share that, Michael. Okay. I just want to point out that on our fabulously provisioned website at ottawa.rasc.ca, as of a couple of months ago, under the Fred Lossing Observatory section, we now have access to real-time sky observation conditions at Fred Lossing, including, as you'll see down here, SQM measurements in real time from Fred Lossing. Now, they're not calibrated in the way that you've described, to my knowledge, but still, it's another one of these reasons why membership with Ottawa RASC has benefits, i.e. you can assess conditions at FLO before packing up and heading off out to Almont. That's the end of my share. And now, are there any questions for Jim?
Mick, you'll also see a comment in the chat room from Flo that there is an SQM online there.
Okay. That is from who?
You typed that to Jim. There's an SQM online near Flo.
Yeah.
Accessible from the Flo page.
Okay, that was me. So yeah, Rick Wagner has more information about that. Are there any other questions for Jim, or can we move on? I take it we can move on. Okay, so Chris, if you can go back to the main deck, please. And speaking of Rick,
here I am.
Skylights for 2021 and 22. Silly me.
So we've got, well, first I'll say Happy New Year to everybody and good evening. We have a lot of interesting events that the Centre Council has scheduled for this year, put on especially for you people. Before I get into the list, I should mention that unfortunately for late risers, most of the events will take place before sunrise this year. But since that's the most beautiful time of the night, maybe it'll encourage more of us to become early risers. And the other point is most of these are conjunctions of planets where two planets get close together. And unfortunately, almost every single one of them, the closest approach of the two planets is while the planets are on the other side of the Earth from us, visible from Australia or someplace. So what that means, though, is that we get the benefit that the conjunction is almost as close the day before or the morning before or the morning after, which gives us two opportunities to see the close approach in case one of them is cloudy. So I hope everybody's raring to get out observing because our first event is tomorrow. Chris, next slide, please. So Venus is in inferior conjunction sometime tomorrow night, but it will be 5 degrees north of the sun, which means that if you're very careful, you will actually be able to see it either tomorrow during the day or Sunday. Sunday's forecast is not very good, but tomorrow's forecast is very good. So if you're not daunted by looking just 5 degrees from the sun, you should be able to see a very, very thin crescent Venus. Now, I must reiterate, this is a dangerous observation. So you shouldn't do it unless you're very experienced, unless you're confident you can do it safely. I did this a few years ago, and my process then was to put a solar filter on my telescope, align the telescope to the sun so that I know I'm pointed in the right direction. Then I move the scope to Venus, make sure the solar filter is still on, look through the telescope. If there's no sun visible in the view, then I take the solar filter off, and there's Venus. So I never move the telescope. Once I'm starting observing, I never move the telescope without putting the solar filter back on first. So again, if you're a confident and experienced observer, this is something that's it's a really nice thing to see. Next slide, please. Nothing much happens for the rest of January, all of February, and most of March, so you might as well just sleep, I guess. 28th of March, however, we get a nice grouping of Mars, Venus, Saturn, and the Moon, again, before sunrise, all clumped in down near Scorpius, which means Antares is in the area there as well, which will make it quite interesting. Next slide, please. Just about a week later, because all the planets are congested in the dawn sky, we're going to get a lot of events. Mars and Saturn will be tight in the dawn twilight, with bright Venus nearby to help find them. You can see on this chart, they're actually sort of blended together into an oval on the right side. So again, best opportunity to see this is on the 5th or the 6th in the morning sky. Next slide, please. 27th of April, we get another very pretty grouping of Venus, Jupiter, and a thin crescent moon in the dawn sky. And just a few days later, next slide, please, we get the closest approach of Jupiter and Venus. This will be very close and very bright in the dawn twilight. So that'll be quite an interesting thing on the 30th of April or the 1st of May. Next slide, please. 15th of May, we get a nearly ideal total lunar eclipse. It's going to be fairly low in the south. However, it starts fairly early in the evening. And you can see in the chart I've shown here, the moon is just starting to come out of totality as it's crossing the meridian. So the whole thing is basically takes place in the evening. And Antares and Scorpius are very nearby, so it's a great opportunity for some dramatic views and nice photographs. And something a little cherry on the top, if you will, right in the middle of totality, the moon is going to occult a 6.25 magnitude star. If you've never watched the moon occult a star, it's quite an exciting thing to see. It just winks out almost instantaneously. Next slide, please. 29th of May, the congestion in the dawn sky continues. Jupiter and Mars have a close encounter. This is going to be quite interesting because Jupiter is much brighter than Mars to your eye. But if you look at them through a telescope, you'll find that Mars actually has a much higher surface brightness because it's much closer to us and the sun than Jupiter is. So that'll be a neat observation to make. Next slide, please. This is middle of June, and it's a chance to see all the major planets in one night. I did this once before, back about 25 years ago or something. In morning twilight, Mercury will be rising. It's going to be low, so it'll probably be the hardest one to spot. And at that moment, Saturn is just about to cross the meridian. From west to east, from Saturn, Neptune, Jupiter, Mars, Uranus, Venus, and then Mercury, all in a relatively straight line. And let's see, what else have I got here through the week? Yes, through the week, the moon will be scooting by just below all the planets. And then finally, towards the end of the week, going by north of Venus and Mercury. And if you're a real keener, you can actually, in the evening before, you can actually find Pluto at about 14th magnitude. You'll need about a 10-inch telescope probably to see that. And then you can also see on this chart that asteroid number 4, Vesta, is not far from Saturn. So you can pull in an asteroid as well to make it a full collection of solar system objects. 26th of September, next slide, please. A Jupiter opposition. Now, we just had one last year, just this past year. However, Jupiter was way down south. The seeing was generally appalling. This time, it's twice as high in the sky at opposition. And not only that, but this is going to be its closest opposition in 70 years. So it will be larger, brighter, higher, and better seeing, so better for looking and imaging. Next slide, please. 24th of October. Now, in spite of the way this chart looks, this is actually going to be a daytime observation. The moon is going to occult the planet Mercury. Now, counterintuitively, because this will happen fairly close to the sun, the moon is going to be an extremely thin crescent and will actually be very hard to see. In fact, you may not see it at all. However, you will be able to see Mercury with a telescope. It'll be at magnitude -1. And then you'll be able to watch as the limb of the moon gradually sweeps across it. Now, again, this is a daytime observation, so you have to be very careful to make sure you don't get your scope pointed at the sun anytime. Same warnings as I gave for the Venus opposition tomorrow, or a conjunction tomorrow. Next slide, please. 8th of November, another lunar eclipse. Good heavens, we're swamped with them. This one, however, is less ideal for observation. You can see this is the view here as the moon is just about to set, just coming out of totality in dawn twilight. So the whole thing takes place after midnight. However, it's going to be an interesting area of sky. You can see the Pleiades and the Hyades are nearby. It'll be definitely worth getting up for. And finally, next slide, the 8th of December, Mars is also having an occultation this year. And again, this one will be much higher in the sky than it was 2 years ago. Now, unfortunately, it's not going to be quite as close as it was 2 years ago. I think it's about 25 or 30% further away. So it'll be a little smaller, but it'll be much higher in the sky. So the seeing should be better. And what's really amazing is that right near midnight, right at the moment of opposition almost, it gets occulted by the full moon, high in the sky. It should be just an astonishing view, excellent for videoing and imaging and just watching if it's all you have to do. So that's what I see coming up for the coming year. Any questions?
Beauty, Rick, thanks for all that. I do have a question.
Okay.
Why didn't the RASC Council organise with sufficient advanced warning any decent comments in the coming year?
Oh, those we keep secret. They're always a surprise.
What's the purpose?
Just surprise is nice.
Okay. Anything in the boxes for Rick?
Nope.
Not that I can see. Chris, am I
I
missing
don't see
anything?
any either. Nope.
All righty. Thanks, Rick.
Thank
and
you.
now we can move on to observations. And first off the block will be Bob Olsen.
Hi, folks. This picture was sent to me by my sister. She lives in Edmonton. Early evening on December 6th, she caught Venus hanging over top of the moon. This was taken with a point and shoot camera. The separation between these two is 3 degrees, so they're really pretty close together. She had it obviously zoomed way out. This is an astonishing handheld photo to me. Everything is sharp and clear. This never happens to anybody. Okay, next image. This is one of the challenge objects. It's a 4-hour exposure. This galaxy is in the M81 group, which is near the Big Dipper. It's about 8 million light years away. The faint pink areas, which are not showing up very well on my screen, they are star forming areas. And this can be seen apparently with 10 by 50 binoculars. I've never looked at it that way, but it was a pretty spectacular thing to image for sure. Next, please. This is the California Nebula, or a bit of the California Nebula. They're very appropriate that Jim was talking about short focal length cameras, lenses, and getting that wide field view. This is a narrow field view with my big my big Newtonian. And I think it's showing about 1/5 of the California Nebula. This is hard to see visually because we don't see red very well in the dark, and it's lit up by a nearby star, spraying it with ultraviolet light and exciting all of the hydrogen molecules in it. Menkib is the nearby star. Thank you very much.
Okay, thanks, Bob. Next is Andrea, I believe.
Hi, hello and Happy New Year. This first image is an image of the Cocoon Nebula, and it is obviously a red emission nebula, kind of like the Rosette Nebula, and it's found in the constellation Cygnus. And what is kind of fun about this pretty nebula is there's also a dark trail that follows it, and that trail is known as, well, I forget what it's known as, but it's just nice to see. Part of the fun is seeing the little trail that comes from it. This was shot with my Hyperstar lens on a Celestron C11. I did use a filter because this is a nebula, so it works really well with a hydrogen filter, and it was a dual band filter. And it's about 540 millimeter focal length with the ASI 533 color camera. Next. I'm sorry, next, Chris? Oh, thank you. This image is the Veil Nebula, and this was shot with a wide refractor. It was shot with a Red Cat telescope, because this is actually a huge nebula. It's a supernova remnant, actually, and you can see how the two curves show where the debris is exploding out from some explosion long ago. Again, this supernova remnant has a lot of emission in hydrogen and oxygen, so I used a dual band filter. It was the L-enhanced filter, and I used a very wide telescope and the ASI 2600 camera, which is a big sensor, making the field of view very, very wide. And I think it's nice because you can actually see the whole complex. Next. This is a galaxy known as IC342. It's in one of the northern constellations. I've forgotten which one, but it's really, it's quite a big galaxy, but it's very faint because it's over such a wide area. And it's not your typical color of galaxy. It has a brownish color, and apparently this is because it is very close to the Milky Way, and we're looking at it through all kinds of dust. And in fact, when I was putting the image together, I kept thinking that there was noise in the background, but I've decided that the noise is just a lot of dust. So it's a dusty galaxy, and it was shot with the hyperstar lens on the Celestron C11. Next. This is another galaxy, and I think what's important to distinguish with galaxies is that I tend not to use any filters with the galaxy other than a basic, what we call a UV IR cut filter, which is sort of your basic filter that you would use for astronomy. But galaxies do not do well with dual band or narrow band filters. Therefore, you ideally want to take pictures of galaxies when it's naturally dark out. So during the new moon is the best time for galaxies, and far away from Jim's Bortle 9 skies is better for galaxies. This is M33. It is the Triangulum galaxy found in the Triangulum constellation. But actually it's known for being really, really close to the Andromeda galaxy. And if you are observing and you're looking at Andromeda, M33 is not very far away. And also shot this, hang on. No, this one was shot with a wide angle telescope with the Red Cat. Yeah, with the Red Cat. It's actually a very big galaxy. So a wide angle, small refractor with the ASI 533 color camera. Next. This image was shot the exact same night as M33, so it was also shot with the Red Cat and the 533 camera. I love this image because it has M78, which is a reflection nebula. So it has the blue, and the blue comes from hot young stars that emit blue light, and they are lighting up all the dark dust all surrounding M78. This is found in the constellation Orion. And you may have seen photos of something called Barnard's Loop in Orion. And that is a very large round circle. It's huge. It surrounds the entire complex where you would find the Orion Nebula and the Horsehead Nebula. And this is only but a small piece of Barnard's Loop. This was shot with the Red Cat and the ASI 533 color camera. I thought that I might have to use a hydrogen filter to bring out all of the red, but this all came out just naturally with the color camera. So I was quite pleased how that turned out. In the constellation Orion up in our sky right now. Thank you.
Bruce, before we hand off to Richard, I have a point I'd like to make.
Go ahead.
As Andrea, by the way, some beautiful shots, but as Andrea well knows, and Bob to a lesser degree, as part of the provisioning for our fabulously well-provisioned website, I am asking that presenters of observations also give me a text file with some of the background to the image. That can be technical specs, viewing conditions, impressions of the objects as they're being observed. So this, I guess, is forewarning to observers that I will continue to harass for those background notes for the website. Thanks.
Okay, so my background notes here. So I didn't see very much in the way of clear skies this month. The only time we seemed to be having clear skies was when the moon was pretty bright. So anyway, when the moon is bright, I get out my big telescope and long focal length and zoom right in on it. So these are all taken with my 8-inch Schmidt-Cassegrain telescope with the ASI 178 MC color camera, but not much color on the moon, of course. So in fact, I believe on all of these, I just in the processing, just took the green channel to get these black and white images. So my process is to take about a 3-minute video and then use PIPP and auto stacker to pull out just a few of the best frames and stack those up. And then I've been experimenting with Registacks to try and use some of the wavelet processing to sharpen the image afterwards. What you get is what you would see with your eye in just those fractions of a second when the seeing is beautiful. So it gives you a static view of what you might catch a glimpse of with your eye. Anyway, this is Mare Imbrium on the Terminator, so it's nicely bisected by the Terminator. And with the low lighting there, I really like the way you can see all the little hills and ripples in the lava field in the center of this mare. Also down on the lower right-hand side, you can see the Alpine Valley. Next one, please. At the other end of the Terminator, the south pole of the moon, a lot of nice features in this area. On the right, you can see the straight wall, a very thin, straight shadow of a line there. And then a fairly prominent crater just coming out of the shadows is Tycho, with its very tall central peak, with just the tip of the peak being lit up in the basin of blackness around it. And then just a little bit farther south to the left is Clavius. And again, you've got a nice arc of its far wall just being lit up by the rising sun, and several of the craters on its basin floor are starting to show up as well. Next, please. This is the same view the following night on December 13th. So now you can see that both Clavius and Tycho have their basins fully lit up. You can see the central peak in Tycho with its little shadow behind it, many, many craters within Clavius on the left, but the straight wall has disappeared. We can just barely make it out between those two craters on the right-hand side of this particular image. So the shadow conditions on the moon really make a huge difference to what details you might see on any night. Next one, please. Now we've got to flip ourselves 90 degrees for this view. I changed the orientation, but there's Tycho again at the bottom right-hand corner of the frame. And because this is on the 16th of December, the moon was getting towards full, and Tycho's rays were starting to become quite prominent, especially the one shooting up over Mare Nubium to its north. And there in the middle of this frame is the lunar challenge object for this month, Lacus Timorus. Tiny little lava flow basin in there with a lot of interesting details around its edges. And that's all for you. Thank you.
Thanks, Rick. And now to Paul.
Thank you, Mick. Well, good evening, everyone, and Happy New Year. Well, as Richard just pointed out, December has been a bit challenging in our neck of the woods for clear skies on moonless nights. As Murphy would have it, this is probably linked to astronomy-related Christmas presents, especially in the last couple of weeks. That's my theory, anyway. Anyway, while Comet Leonard has been putting on a pretty good show for folks in more southerly latitudes, the windows of opportunity at our latitude for this object have been quite short, limited to less than an hour, either just before sunrise or shortly after sunset. And even in those windows, the comet was hovering very close to the horizon, requiring very clear skies to see it. I tried on a number of occasions to see this, but only to be thwarted by distant low-hanging clouds in an otherwise clear overhead sky. It's been a bit frustrating, but it's a challenge. Anyway, on the morning of its closest approach to Earth on December the 12th, the sky did finally cooperate, and I was able to get this view just after 6 a.m., about 20 minutes after the beginning of dawn. The comet had only risen to about 3 degrees above the horizon by that time, and the sky was already noticeably brightening. I couldn't see the comet at all with the naked eye, and even with 15 by 70 binoculars, I'm not sure that I saw it at all. It might have been just my imagination. The background sky was just too bright for that. Fortunately, the camera and some image processing did capture the view. I shot this with my Canon RP and a 200mm f4 lens on an Ioptron sky tracker. It's a combined stack of 9 15-second exposures at ISO 400. Next one, please, Chris. So this image, it also captured the globular cluster M10, which you can just barely see above that portion of the sky where it would have been washed out. Again, these objects were just on the rise here. I couldn't see the globular either visually through binoculars, just courtesy of the camera. So the next slide just shows a zoomed in version of that image. This is obviously just a crop from the previous slide. The tail length here is about 0.5 degree, roughly about the diameter of the full moon. I've tried to capture this again in the last couple of weeks, even just a few days ago, but the steadily increasing elevation and persistent clouds have just not made that possible. We're just, from our point of view, it's basically just in the murk of the twilight sky. Anyway, that's probably our last opportunity to see this comet from our latitudes. It is putting on a nice show in the south, and there are some excellent images of that available on the net. So if you haven't seen any of those, check it out. It really is a beauty. When it flared up just recently, tail lengths in excess of 40 and 50 degrees have been reported by observers in dark, pristine skies. So. Too bad we missed this one, but I guess we got a good one last year with Neowise. Anyway, next one, please. So the last few slides I have tonight are just preliminary images of new camera I got to replace my recently and dearly departed Canon 60DA. It suffered some sort of terminal failure, and unfortunately, Canon no longer supplies replacement parts. So I'm in part to blame for the poor skies of late because of this new acquisition. The new camera is in fact an ASI 294 MC Pro from ZWO. It's a one-shot color camera built around a very sensitive CMOS sensor. I initially thought about replacing the 60DA with another DSLR or mirrorless camera and then getting it modified for greater H-alpha sensitivity. But when I started comparing the specs for the ZWO and similar cameras, I opted for a one-shot color camera specifically designed for astronomical imaging. The Peltier cooling of the sensor to 30 degrees Celsius below ambient temperature, and the sensor itself with a quantum efficiency in excess of 75% were pretty strong selling points for me. I'll do a more thorough review of this camera once I've had a chance to do more imaging with it. But for now, I just wanted to share a few test shots because of the way they actually kind of surprised me. One of the major factors that drew me to this camera was the span of accessories available for it. Specifically, ZWO makes an adapter that allows Canon lenses to be used with the camera, so I could continue to use the same collection of lenses I've been using on the 60DA. The adapter also has a very desirable feature built into it, namely a removable filter drawer that allows me to use my 48mm astronomical filters for imaging with the camera lenses. The filter holder just pops into the adapter without having to remove the lens from the camera. So that makes it very fast, very easy, and very attractive. So this is actually one of my first test images with the camera, and was taken with my Canon 50mm f1.4 lens and a UV IR block filter. I had it mounted on an Ioptron sky tracker. I was quite surprised with this image because of the number of faint stars it picked up around the belt of Orion. This is only a 6-second exposure. It's a totally unprocessed raw file. And even at 6 seconds, you can see that the Orion Nebula is pretty much completely saturated. Oh, and by the way, those are tree branches in the lower right corner. I should have set up my tracker in a slightly different location, but didn't want to move it given there were incoming clouds due shortly. Surprise, surprise. So given the sensitivity of that I saw in this very short exposure, I had to try an H-alpha image. So I swapped the IR block filter for an H-alpha filter in just a few seconds. And the HR filter has a 12 nanometer bandpass. Next one, please, Chris. So this is the shot with that filter. Now, normally, when I've talked about doing image processing and astrophotography generally, normally I wouldn't really do narrowband imaging with a one-shot color camera. But with the quantum efficiency of this sensor and the strong H-alpha feature of Barnard's loop, which Andrea mentioned, which is right beside Orion, I was certainly curious to try it. So again, this is a 180-second exposure with that filter, and again, there's no processing here. This is as it came out of the camera. I was very pleased with the result. Barnard's loop is very evident, as is the H-alpha nebulosity around Alnitak and Orion's belt, and around the Horsehead Nebula region. And unfortunately, again, you can see the tree branches encroaching into the view at the right side. So my last image is a merger of these, well, of two images taken with this camera. Next one, please, Chris. I did have the opportunity to also shoot a few longer exposures with just the UV IR block filter. And this slide is a 180-second exposure. And I thought the star field was crowded in a 6-second shot. Wow, I don't think I've ever imaged Orion looking this busy. It's just awash with really, really faint stars. Again, this is just a single unprocessed, uncalibrated raw image with one exception. I merged the 180-second H-alpha shot with this 180-second full color view to bring out the reds of Barnard's loop under the other nearby H-alpha regions. So long story short, I'm very encouraged by the response of this camera with these very limited tests I've done to this point. And I'm really looking forward to using it on the 11-inch Edge HD scope, especially with the f7 focal reducer. The adapter used to attach the camera to the telescope also incorporates a filter drawer, again, allowing me to easily swap out filters in that application as well. I think this should lead to some interesting results that I'll share as I get them. And I'll try to avoid the trees. That's it for me, everybody. Clear skies and stay safe.
Good stuff, Paul. Some lovely shots there. Thank you.
Thank you.
So the observing challenges last month from, sorry, Chris, I presume that I am presenting this, yes?
Yes, you are.
Okay. So yeah, the NGC 2403 is the beginner challenge, NGC 1499 as the as the intermediate challenge, Teeny Weeny Palomar 2 was the advanced challenge, and as Rick showed us, Lacus Timoris as the lunar challenge. So for this month, Chris, next. We have the Little Dumbbell Nebula, Messier 76, a fairly popular object in Perseus. Next, NGC 896, a particular nebulosity in the western part of the Heart Nebula is the intermediate challenge. 7.5, you're going to need some decent equipment, but should be fun to get. Next one. NGC 2474 and 2475, a pair of interacting galaxies, not to be confused with the antennae or other popular ones. This is a harder target in Lynx, and I would hope we can get some interesting results from that. Then for the lunar challenge, Montes Riphaeus, an irregular mountain range on the west-northwestern edge of Mare Cognitum and the eastern edge of Oceanus Procellarum. So, as always, lunar challenges will depend on your seeing conditions and the phase of the moon and so on. Good luck with those. There's the recap. Next slide, please. Fred Lossing Observatory is functioning. Just be aware that the protocols relating to the use of the site are likely to change sometimes rapidly as Omicron works its way across the country. So do check back to the FLO page on our fabulously provisioned website for the most recent rules regarding use of the observatory. Next, please. Okay, and next star party, 4 members at FLO, 29 January. You'll be informed if there are backup dates need to be applied there. It'll have a waning crescent moon, so hopefully clear skies and a good session to be had out there. Our club information, the usual stuff, FLO Director, Rick Scholes. The library is obviously not functioning at the moment. Membership info from Art Fraser, Sky and Telescope renewals through Stuart Glenn with the members discount. Next. We had a total of 97, not bad for a Friday night in January. There is our list of speakers and presenters. Next. Thanks to all of those who have presented. Next meeting will be 4th of February, same time, same back channel. And I hereby announce I am going to modify the sequence of presentations under my heading of views from a Southern perspective in order to respond to Dave Chisholm's challenge about the Southern skies and the supposed lack of, amongst other things, a Polaris Australis. But we'll come to that next month. Meanwhile, wishing you all well and see you in a month's time. Thank you.
And congratulations, Mick, for successfully getting through your first meeting and doing it so well. I look forward to working with you over the next 2 years.
Okay, and it was almost on time. So there we go.
Ahead of schedule. We owe you 10 minutes. Congratulations.
Okay, thank you.